thing that we're focusing on today is this idea right here. This thing right in the center. The idea of a what? What is this? Limit. Put your computers in tablet mode. I will start taking off a whole point off of your class performance grade, which is 20% of your grade. So can anybody read this out loud to me? What does this say? Can someone read it? If you're going to communicate this out loud, what does it say? Yeah.
The limit of f of x as x approaches c is L.
Yes. Yes. The limit of f of x as x approaches c. I kind of like doing this. The limit as x goes to c of f of x is fine too. The limit of f of x as x goes to c is L. That means you can get arbitrarily close to L. You can get as close as you want. Here's an operation. I go halfway to the wall. I go halfway to the wall. How close can I get to the wall? As close as I want. So therefore, the limit of that operation is the wall. In terms of numbers, let's say I was at 1 unit away from the wall. 1 unit away. If I go 1/2 plus a quarter plus an 1/8 plus a 16th plus a 32nd, how close can I get to the wall? How close can I get to the wall? It's the same exact thing. You can get as close as you want. You can get infinitely close. Close as you want seems arbitrary, but basically it means is no matter what number you name, I can always get within that distance. Within that distance. In that case, it was half. You can always get closer. You can always get closer. If you say 1/1000th of an inch, I can get within 1/1000000000th of an inch. Always, always, always. So we're going to look at a few straightforward ones using our calculator first. So the idea is, take a look at this. Don't write it down, just take a look. It says evaluate each of the following. What is the limit of x squared as x goes to 2? Can you tell me what it is? What's the first thing you always check to see if you're asked a limit question? What's the limit as x goes to 2 of x squared? There's no trick to this. 4. Why? Why do you know it's 4? What can you do? You can plug in 2, right? You literally can plug in 2. The operation I gave you before, getting halfway to the wall, getting halfway to the wall, getting halfway to the wall, can I ever get to the wall? No, not unless I have an infinite. You don't get to the wall. But here, can you get to the wall? Yeah. Can you plug in 2? Yeah, you can. So this is the first thing you always check. When you're given a limit to evaluate, always check, can you plug in the number you're going to? I can give you some math. You're going to get some ways to analyze limits. Option 1, option 2, option 3, option 4. I'm going to give you some big, huge, terrible looking limit, and you're going to think like, oh, I have to use option 1, no, that, no, 2. None of them work, but then you realize, oh, I can just plug in 5. The answer is 7, whatever it is. So always check, can you plug in 2? So the way you would see this, is you plug this into your calculator. Do you know how to plug numbers into your calculator using a table? Yeah. Okay, so take out your calculator, everybody. Let y1 equal x squared. Now, if you wanted to fill in these values just using a calculator, could you just fill these in? Sure. What's 1.9 squared? Can someone do that on the calculator? What is that? What's 1.9 squared, Natalie? 3.61. 3.61? What's 1.99 squared? 3.9601. You're doing 3.61 to the second, or sorry, 1.9 to the second.
You just do the x squared button.
Or the x squared button, right? So there is a button, but you have to type this in every time, right? So it's you're manually entering it. There are ways to do it faster because is the function always going to be this simple? No. Yes? No. We're going to do other limits. Mr. Seamon based an entire math class around x squared. No.
I think you meant every single time.
No, every single time we do this one. Yes, you are correct. So you could manually enter each number. You could manually enter the function every time. But could this get arbitrarily big? It could get complicated. And is it really easy to enter a function wrong? Yeah, especially rational functions that you've seen before. Polynomial over a polynomial. You misplace one negative sign or a division sign, and what happens? It like blows up. You start getting numbers that don't make sense. Or theoretically, you recognize it. So what you can do instead is enter the function as y1 on your calculator. So let's say we entered x squared as y1. Let me see if I actually got this to load. I already licensed this, but I'll do that later. Activate your license. Yay. Hold on one sec, kids. I'm going to activate this. What it's going to look like when you do it on your calculator, I'll show you a little bit later today, is on your main screen, you're going to type this, 1.9. If you type y1 parentheses 1.9, it'll evaluate the function, the first function at 1.9. Why is this really helpful? Because you can do anything you want. You could do y1 evaluated at 2.001. And what do you not have to type out every time? The square. In this case, that's minimal, but could that be bigger?
Yeah.
Yes, it just takes this number. It takes this number right here. It takes this number right here and it plugs it in there. So if you fill this chart in, 2.001 squared. Could you finish it for me, Natalie? 2.0, what is it? 4 point what? 004. So here's the thing. You can fill all these in, and then you can visually look what's going on. What does it look like it's going towards? What does it look like it's going towards? It looks like it's going towards 4. We know it goes to 4 because you can plug in 2. The thing is, showing it visually is not the same thing as proving a limit. Showing it visually is not the same thing as proving a limit. What about this one right here? X goes to 0 of 2x plus 3. What's that going to go to? When x is 0, what's the output going to be? 3. It's going to be 3. So when you test numbers around it, I'm going to have you fill in charts like this. You're going to go as close. So what's 1/1000th to the left? What's that going to be? What's 1/1000th less than 0? Negative 0 point what? 001, and then negative 0.001, and then negative 0.1. And then what about to the right? It's the exact same thing. It's symmetric. 0.001, 0.01, and 0.1. Could you fill all those in? Absolutely. And if you look at the chain of numbers, it should go to what? 3. It should go to 3. It should go to 3. How is this one different right here? Can someone tell me how this one is different? What's different about this next one right here? What's different about it? Yeah, can you plug in 0? No, you can't plug in 0. So let's take a look at this. 0, we do the same numbers to the right and to the left. See if you can fill in this chart right now with minimal use of your calculator. Do that right now. See if you can fill that in with minimal use of your calculator. How's that? Better? Thank you. You're just falling apart today. Okay, that's what 1 over x looks like, right? So what happens as you go to 0 from the right? What happens as you go to 0 from the right? What does it do? It goes up. How far up does it go? It goes far up as you want. 0 from the left, how far down can it go? As far as you want. So what do you think we say the limit as x goes to 0 is?
0.
So 2 possible lengths, 0, infinity. From the left, it goes to negative infinity. From the right, it goes to positive infinity. Those don't agree. They're not the same. So this is said to does not exist. It doesn't exist because for the limit to exist, the limit has to be singular. It has to be one thing. It does not exist.
Wait, why?
Because if you're approaching from the left, what is it going to? Not the same thing as going to the right. Is negative infinity the same thing as positive infinity? No. Our limits are going to look like 2 things. When you're traveling along, let's say there's one discontinuity. Let's say that point was 2, 4, and this was the point g of x. What's the limit as x goes to 2 of g of x from the left? From the left, what do you think? If you're approaching from the left, if you're going to 2 from the left, what is it getting infinitely close to? 4. What about the limit as x goes to 2 from g of x from the right? What's it going to? 4. This is the same number. So therefore, what do we say the limit as x goes to 2 in general, not from a side. It means both sides. Does it agree? Is 4 the same thing as 4? So we say the limit is 4. But over here, is the limit the same from both sides? No. So we say the limit doesn't exist.
But the graph looks like it's 0 is the limit.
No, this one's going infinitely down. This one's going infinitely up. 0 is right here. Is it approaching that point right there? Is that point in the center of it?
Towards infinity, it's going.
No, look at that. 0 is in the middle.
Yeah.
What's happening?
Oh, it's x goes to.
X goes to 0. Yeah, not infinity. Yeah. Go to 0, going to 0. Now, I see what you're saying.
Yeah, sorry.
Okay, no, don't apologize. What about this one? What's the new thing we added in here? What's the new thing we added in here? Yeah, if you factor this thing, you end up with x plus 3, x minus 3 over x minus 3, right? What cancels? So what happens at x equals 3? There's a hole. How do you get the y-coordinate?
Well, you enter 3 back into the equation, it's 3, 6.
Yeah, you enter 3 back in the equation. So we think 3 is 6, but can you plug 3 into the original equation?
No.
So we think this is the limit, but is it in the domain? 3 it's x such that x doesn't equal 3, right? So is that number on the function? No. If you graph this, what does it look like if you graph that? What does it look like? The x minus 3's cancel. It's a line. It's just a line with a hole at 3, 6. That's all it is. It's a line with a hole at 3, 6. But if you wanted to make a table to feel better about the limit, to believe in the limit, you would do 2.999, 2.99, and 2.9, 3.001, 3.01, and 3.1. Now, I said you could do this a little bit more in a little bit more straightforward manner on your calculator, and this is what it would look like. What was that function? It was x squared minus what?
X squared minus 9 over x minus 3.
Divided by x, it's, sorry, and what, I made a mistake when I typed that into my calculator. What is it? What's the mistake? What? Yeah, if I did that, that would be divided by x and then the whole thing minus 3. So I do parentheses, go back over to here, second insert there. So now y1 is that function. So what can I do now? So we quit this, sorry. Well, hold on, I want to show you the first way. Watch this. If I hit vars, y-vars function, y1, what can I plug in? I can plug in anything I wanted to. Oh, good. Did I put 2 parentheses?
Right there.
Thank you. So I go back to here. So second entry. Hey, look. So what could I do now? Vars, y-vars function, y1. What could I plug in? 2.99999. I get even closer, right? What is it doing? Is it actually that? Is it actually 6? No, it's rounding at a certain point. It rounds at a certain point. You can control when it rounds. It goes to, I think, 12 or 13, 10 decimal places before it gets real ornery. Point is, this is how you can manually check it in. Plug it in, evaluate. Now, what's an easier way to do it, though? What do you see in the middle there? There's a table. How do I get to table?
Second graph.
Second graph. Oh, I just hit graph, not second graph. Yeah. But is that the line x plus 3? The only thing that's missing is that if I try to evaluate 3, it's going to come out with an error, right? So if I go back to this, look, watch. If I do vars, y-vars, if I try to evaluate this function at 3, what do you think is going to happen? No, it's going to divide by 0, right? Because can you plug 3 into the original equation?
No.
No, you can't. So I want to do second graph to get the table here. So how do I manipulate these, Natalie? Do you remember?
Yeah, you have to delete.
Everybody? What's it doing? It's going up by 0.01, and what's, oh look, error. So is this the exact type of information we want? Yeah, so when we look at this chain here, we already believed it went to 6, right? We believed it went to 6, but now does this kind of show that it goes to 6? Yeah, it does. Okay. Okay, so let's change it up just a little bit. Let's change it up just a little bit. What's different here? What's different here? Now, again, you could factor in the 1 plus h minus 1 times what? 1 plus h plus 1. If you wanted to, you could. That's the difference of squares right there. Okay? It is. It's something you could do. Do you want to do that in this case? No. Not really. Can you plug in 0 into this function? No. Can h be 0?
No.
Yeah, the domain is h, sorry. And we'll make this, ready? H such that h doesn't equal 0. So we really want to make a table of values here. We really, really, really want to make a table of values here. So if we were to use our calculator to do this, we go into y equals, and what was it? I need to make sure I use proper parentheses. 1 plus, oh, that's 11, right? I don't know why it's hitting that twice. Like this. Squared, right?
Yeah.
Minus 1 parentheses, like that. Divided by what? Well, it's x. We're just calling it x here, right? Okay, so then we want to be around what number? What's x in this case going to? We want to be around 0. So we go to table set, and instead of table start, where do we want to start? We want to start a little bit left of 0. So maybe, how about negative point what? We want to get a little bit further away. So I kind of like going to point 0.01 and then have the step be 0.001.
Do you have to do it that way, or can you do it so you can just plug in the numbers?
You can just plug in. No, you can just plug in the numbers. You can. I like it. I kind of like it this way because you can just do it once and then scroll a little bit, but you have to choose wisely.
Yeah.
If you choose, either way works as long as you get the numbers you want. So if I go to now table on this thing, look what it does. It's getting closer, closer, closer. And what's it? Oh, error. Did we expect that error?
Yeah.
But here's what's really cool. Did we have any real intuition about what this limit was going to be? Did I ask you what the limit was? Before, Andrew was like, oh, this one's 6, right? We did that before? Do you remember the last question? We had an intuition about what it was going to be. But now, what's kind of cool about this? This tells us, or it shows us that what do we think the limit is? That is way bigger than I wanted to be. There we go. What does it look like the limit is?
2.
Looks like the limit is 2. Was that, quote, obvious based on what we were looking at to begin with?
No.
Let me cut this. I'll put this away over here. Put it over here. It was not obvious. It was not obvious. But judging by this now, it looks like, what was this, the limit? So it's the limit as h goes to 0 of 1 plus h squared minus 1 over h. It looks like this goes to 2 as the limit. So our calculator was really, really helpful there because was this obvious right here, what that was? No. We don't have a way of doing that yet. We don't have a way of doing that yet. Or do we? What was the factored form of that numerator, by the way? Do you remember? It was what? 1 plus h minus 1 times what?
1 plus h plus 1.
Plus 1, right? Like this? Over what? H. Can we simplify those pieces a little bit? What's this turn into? What's the yellow turn into right here? What's that turn into? What does that turn into? The yellow. What's 1 plus h minus 1? H. So the yellow turns into that. And this turns into h plus what? What does that turn into? 2. And the denominator, oh, what cancels?
H.
And what are you left with? We just filled in the hole. When h goes to 0, what happens to that? Yeah. When h is 0, what is h plus 2? Does that match what the calculator told us?
Yes.
Yes. So don't forget to factor. Don't forget to factor. Okay, so this is what I'd like you to do now. Try this one for me. Here's the graph. So the thing we had before was a function, and we used our calculator. Red one say.
The limit of f of x as x approaches 0 from the right.
So go to a little bit to the right. Oh, you're on the right, and now you go towards it. What are you getting infinitely close to?
2.
Yes, as you go to 0. So when you're doing this, x is going to 0 from the right. You're getting infinitely close to what? 2. So then, if you go from the left, it's 0. If you go from the right, it's 2. What's the limit as x goes to 0? What do we say this equals?
Undefined.
Yes, it's undefined. Why is it undefined?
Because it's different from the right and the left.
Correct. The left and right-hand limits are different. Here's a question for you. What is f of 0? What is the function evaluated at 0? When you plug in 0 into that function, what is the output?
0.
It is 0 because where is the filled in dot?
It's 0.
It's 0. Is it 2?
No.
Because what is at 2?
That's a whole.
Open dot. Can you get infinitely close to this?
Yeah.
So you get infinitely close to it. So does it matter if the function, no, it doesn't matter if the function is defined there. As long as it's a whole. As long as it's a whole. Is this said to be continuous? What do you think? No. We're going to talk about continuity later. The easy way to remember it. Do you have to pick up your pen to draw this?
Yes.
Yeah, it jumps, so therefore it's called the jump discontinuity. It's called the jump discontinuity. Okay, so let's fill in 8. Can you plug in 2?
Yeah.
Is 2 part of the domain? Yes. Noah, what about the next one? This one, the red one right here. What's that one going to be? -1, right? -1 squared plus 2 times -1 minus 1. That's 3 minus 2 minus 1 is? 0. Nice. Okay, so what do you always check first?
You can plug it in.
Yeah, you can. Now, you're going towards 2 here. Can you plug in 2?
No.
No. The domain here is x such that x can't be equal to 2. What's your next step after you look at the domain? Simplify. You simplify. Can someone simplify that for me? Someone who hasn't spoken? Whipple, what do you got? Simplify that one for me.
X minus 2
Over.
x minus 2x plus 2.
Yeah, so why is that helpful all of a sudden?
Because they cross out.
Yeah, the x minus 2 cancels and you're left with, this turns into the limit as x goes to 2 of what? Of what? What's it simplify to?
0 over x plus 2.
0? Careful. What's the invisible number right there?
Oh,
1. 1 over what?
X plus 2.
So therefore, what's that limit come out to be? Can you plug 2 in now? All you do by canceling right here, what does this do? That just fills in the hole. Does it change the limit? No. It allows you to find it exactly. So this right here would be a proof to show that it does go to 2. Could you use a table? Absolutely, you could use a table. So it goes to 2. How do you find the x-coordinate of, sorry, the y-coordinate of the hole? What's the, we know the y-coordinate. Oh, sorry, it's not 2, what is it? 1/4. It's 2 comma 1/4, sorry. Natalie was looking at me with a little, like, kind of turned her head and doubted me. Okay, sit down. It's infinitely big. What happens to x cubed? Infinitely big, right? What about x squared? But which one gets bigger faster? Exactly. So all infinities aren't the same. So the key is indeterminate forms. You can't just say infinity over infinity is 1. That's not true. 0 over 0 is not 1. When you divide by 0 or have infinity over infinity, you have to be very, very careful. You have to be very careful. So these, let's get to the board, everybody. Find someone that you love for you to write these out really carefully. So, for example, you would say that this is the limit as h goes to 4 of h squared plus 4h plus 4 minus 9h over h minus 4 equals the limit of, as h goes to 4 of, oh, does this cancel? Does something cancel? What do we have here? H squared minus 5h plus 4. That's what the numerator turns into, right? And then what's it over? Oh, h minus 4. So equals the limit as h goes to 4 of h minus what?
1.
H minus over h minus 4. Does something cancel? Yeah, leaving you with the limit as h goes to 4 of h minus 1, which is 4. That would be great. I can follow all that clearly.
So we wouldn't have to.
Wait, why did I say 3?
Oh, I can't write words.
Yeah.
It's 3. Whew! Okay, let's take a look at a few more of these here. What about this one right here? That one looks terrible, right? Oh man, can you plug in 0? Is h part of the domain? Is h part of the domain? Sorry, is 0 part of the domain? No. So you could multiply everything by h if you wanted to. Sure. If we multiply everything by h, why is that allowed to multiply everything by h?
Because it's just h
Just multiply.
Yes, you're multiplying by 1. Very good, Harmony. That was perfect. You're multiplying by 1. That's it. So if you did that, you'd have h goes to 0 of what? H over 3 plus h minus h over 3 over h squared. Did that help us?
No, wait, no, hold on.
So that was legal because you're multiplying by 1.
It says multiplying by the top and bottom by 3 plus h.
Oh, you want to do 3 plus h like this?
Yeah.
Okay. Is that 1?
Yeah.
Sure. So what do you end up with? 3 plus h over 3 plus h minus 3 plus h over 3 all over 3 plus h over h. Does that help us?
Wait, no, wouldn't it be 3 plus h times?
Yeah.
Oh, times h. Sorry, yep. Sorry, excuse me. Times h. Yep, you're absolutely right. Let's see if this helps us. If we want to actually see if it does, we need to simplify this, right? How do we simplify it?
So it would be...
Well, this goes to 1, right?
Yeah, so 1 minus...
That's nice. 1 minus 3 plus h.
3 or h over 3.
Yeah.
Now you multiply by 3.
Now multiply by what?
3.
Over?
3.
Yeah, it has to be 3 over 3. So what do you end up with? 3 minus what on top?
3 minus 3 plus h.
You see those parentheses I put over 3 plus h? And what's the denominator become? 3h times?
3 plus h.
Yeah. Does the top simplify at all?
Yep.
What's 3 minus 3 plus h? Careful. Where's that? What does that negative do? 3 minus 3 minus h over 3h times 3 plus h. What's it turn into on top? Negative h. 3 minus 3 is 0.
Oh, yeah.
And now you have this. You're like, true. What can I cancel now? What cancels? What's the magic thing that cancels? The h cancels. So what are you left with? Negative 1 over 3 times 3 plus h. So all of that was to say this.
Wouldn't it be 2h?
2h? No, you're just canceling the h's. You're not subtracting. You're canceling. H
yeah.
over 3h is 1 over 3. So, don't apologize. So what does this mean? It means all of that work was just to tell us this. This limit right here is equal to the limit as h goes to 0 of, what was it? Negative 1 over 3 times 3 plus h. What can we plug in now? Can we plug in 0?
You plug in, yeah.
Can you plug in 0?
Yeah.
So what's the answer? Negative 1 what? Ninth. Can you plug in 0 now? We got rid of the whole. You had to do careful manipulation, which effectively comes down to multiply by the least common denominator. We broke the least common denominator into two things, which was 3 plus h over 3 plus h and what? 3 over 3. What could have been the first step if we wanted to do all of it at the same time? What's the LCD of all those fractions? 3 plus h over 3 plus h times what? 3 over 3. This right here is just a fancy form of what?
9 plus 3h.
Nope. It's a fancy form of what? It's the same thing on the top and bottom. So it's a fancy form of what? 1. So can you multiply by it? Yes. We broke it into two steps. Is that totally fine? Absolutely. But when you see compound fractions like this, your whole goal, everybody, this was the entire goal right here. Why did you need to do that? Because it cancels the whole. It fills it in. It fills in the whole, but does it change anything about the limits on the function? No. It fills it in so you can actually plug in what you're going towards. So that's the other maneuver. That's the other maneuver. Okay, so we have a few minutes here. Why don't you get back to the board with somebody new and try that one for me. So you have to, if you want to multiply, you have to multiply by a form of 1, right?
Why? Because we're finding limits?
Well, if I want to find a limit, if I want to find what something equals, if I change it, what's the only thing you can multiply by and not change something? 1. If I multiply by something that isn't 1, you change the system. Like if I want to measure how tall you are, but if I want to measure how tall you are, but I give you taller shoes, I can't find out how tall you are, right? So on this one, the key is, do you have to multiply everything by the same thing? If it's 1, no. If it's 1, no. So for example, just look at the middle here. This is adding and subtracting fractions, right? What do you need? So you have 1 over x minus 1 minus 2 over, can you factor that for me? What is it? Like this, right? I haven't changed anything, do you agree? I'm just expanding this. What do I need to multiply this by to make the same denominator? X plus 1. No, it's the same thing. It has to be, it has to be a form of what? Is that a form of 1? Have I changed anything? Can I now add these together? I now have x plus 1 minus 2 over what? Exactly. So you're looking at this. The limit as x goes to 1. Why is this helpful? What happens? Can I simplify the numerator? Can I simplify the numerator? What does it turn into? This is algebra 1, everybody. Simplify the numerator for me.
X minus 1.
Thank you. X minus 1. Can you now cancel something? Yep. What do you now have? The limit as x goes to 1 of what? Not 0, what? 1 over. Can you plug 1 in now? Yep. So what's it turn into? 1/2. There it is.
Wait, so if we wanted to just find x of this function, we could do just times the whole thing by x plus 1.
You're not multiplying the whole thing by x. You're just multiplying this one because all you're doing there is trying to find a common denominator. Yeah. Go ahead.
If there was no limit sign in front of it and it was just find x, we could do that, right? X minus 1 times x plus 1 to find that function.
It doesn't, but the thing is, this doesn't equal anything. Does this limit, like if it's an equation, something equals something, you can multiply both sides of an equation by anything you want, but you cannot multiply a limit by just something that isn't 1. It changes the whole thing. If that equaled something, let's say this limit wasn't here, right? And it equaled something, you can multiply both sides because when you multiply both sides of an equation by the same thing, that's the same thing as multiplying by 1 on one side. So no, you can't just multiply by x plus 1 times x minus 1 because it doesn't equal anything. You can't balance it out. This one right here, the only hint I'm going to give you is it involves this phrase right here. Somehow you're going to have to use that. Somehow you're going to have to use that. And then on the last one, somehow, what do you think you're going to have to use on this one, do you think? The square root of x. You're somehow going to have to use this. But remember, you have to multiply by a form of 1. You have to multiply by a form of 1. You can get out of here.